Okay. A concept that's very important to understand is the concept of a buffer overflow. What would happen if you tried to access uh, for our weight example? What would happen if you tried to access index 3? Well, we know the last index is 2, one less than the length. So if you try to access index 3, Java will throw that index out of bounds error. Um, so Java's pretty easy to use in that sense. However, there are lots of situations where the data that's coming in is an array, but we don't necessarily know how big it is, and you as a programmer have to check to make sure that it's not going outside the bounds of that array, particularly if you're using C and C++. Those languages don't have automatic array bounds checking, and that can lead to a lot of problems. The reason that buffer overflow is so important, even though we're in a Java class where it doesn't happen, is because it is one of the main ways that code has been compromised from a security perspective in the past 20 years. I have, must have been like 4 or 5 guys I went to college with interviewed at Microsoft. Every single one of them was given a sheet of code and said, tell us what's wrong with the code, and there was a potential buffer overflow. That is, data could be written to an array, and it would keep getting written past the end of the array. Now, with our really simple programs, this doesn't come up, but you need to be aware of it. Heartbleed was an example of a buffer overflow attack. Heartbleed took advantage of the SSL servers. So it would send them a heartbeat message where it would say, okay, the word is love and the number of characters is 4. But if you sent them the word love and said the number of characters is 5, it would send them the next thing that was in memory, whatever it was. So if you send it the word love and then the character count was 10,000, it would send you 10,000 bytes of data back. So theoretically, you could pull all this data out of memory from the SSL server. It was a huge issue. Look up Heartbleed. It's a really interesting case, but that's straight up a buffer overflow error. The programmer didn't check the boundaries of the data. Like I said, Java will throw an error for you, but not every programming language will, and you won't always be working in Java. So be aware of buffer overflow. What we've been doing as we've traversed arrays, what's called sequential access. We access it in sequence, 0, 1, 2, 3, 4, all the way up to length minus 1. We can also access an array randomly by creating a random object and using the nextInt method, just like we did earlier this semester. Notice when we give nextInt a value, it will give us a random integer between 0 and 1 less than that value, which is exactly the relationship between the length of the array and its indices, between 0 and 1 less than the length. So you can just feed in the length to that random.nextInt, and you will get a random number in the appropriate range. And you will do that today. Okay. Then, is this the last thing I want to talk about? Nope. That's not for you. Then we have a few other things we want to talk about. But the next thing we're going to talk about is arrays as arguments. Take a look at this code here, right? So we declare a list of integers. There are 5 items. This code here is just putting numbers into it. So we're just saying I times 2 plus 1. So we're just putting values into it so they don't all start at 0. This code here is what we're interested in. Take a look, pause the video, and take a look and tell me what this does. What this does is it goes from index 0 to the last index, and it takes each number and it increments it by 1. And then finally, this code here just prints out the values in our list. Well, what if we could, instead of, this is probably a common operation to take every item in an array and increment it by 1. This is also a common operation to print out each item in an array, but this is the one we're looking at now. What if we could create a method that would do that for us, and we could call that method over and over again? That's what we're doing here. We have created a method called increment all, it takes as its argument an array of integers. Not an integer, an array of integers. Remember, we talked about how when we declare an array, we use that new keyword, it puts it on the heap. Whenever we pass anything from the heap, we're passing it by reference. That is a pointer to that. That means any changes we make to the array in here affect the array on the heap. So all this does is exactly what the other array does. It goes through from index 0 all the way to 1 less than the length, and it increments the value by 1. That's it. And it is generally a good idea every time you can make something a method. If you're going to do it multiple times, do make it a method. So this is our next assignment for the in-class assignments this week. Create a Java project class called Changeup. Create a method called printArray that prints the contents of an array 1 per line. So it takes in an integer array, I should have specified that, and then it will print each integer on its own line. Then I want you to create a method called change1 that will take an array as an argument, and then will generate a random index. So remember what I said about randomly accessing an array, and then prompt the user to enter a new integer value. So it will randomly pick, okay, index number 2. And then the user will type in 57, and it will put the value 57 into index 2. And then create an empty array of 6 values, this is in the main method, and call change1 on it 6 times. And then print it before the call and after the call, just so we can watch it change randomly as the user enters new values. That's Changeup, and that is in Canvas, and this is going to be the end of our second video. So take some time, do this one. If you get stuck, send me an email, and then come in to the third video.